I'm going to turn it over to Janelle. Tonight, her keynote is entitled A Programmer's Guide to Humans. How about we give her a big round of applause?
Thank you. So to give you a little context for what this talk is about, I thought I'd start off by telling you the story of why I started researching human factors in software development in the first place. So about 10 years ago, I was working on this really great team, disciplined with best practices. You know, we had CI, unit testing, design reviews, code reviews, all that good stuff you're supposed to do. We were constantly working on improvements, but despite all these things, I watched my project hit a wall. So this is my story. So I was working on this statistical process control system that was responsible for detecting whenever something went wrong in the factory and then shutting down the tool responsible. So I've been on the project about 6 months, and we've just worked through the challenges of a major release, tied a bow on it, and we shipped to production. Later that night, we were on this conference call with IT, and I hear this guy just screaming in the background. And apparently, we had shut down every single tool in the entire factory. So, you know, we rolled back the release and tried to figure out what happened. And there was this configuration change that didn't quite make it to production. So, you know, what are you going to do at that point, though? It's water under the bridge, right? So, you know, we fixed the bug, and we shipped to production again. Back on the conference call with IT, and guess what? The same thing happened. So once again, we rolled back the release. But this time, we couldn't reproduce the problem. We spent literally months trying to figure this out, and we were just getting nowhere. And meanwhile, our development team was just sitting pretty much idle. So management told us to just go ahead with the next release. And everyone just started acting like nothing was wrong, but I mean, we couldn't ship anything. About 6 months later, we eventually found the problem, and it was this threading bug embedded in some multi-threaded code, and we couldn't reproduce the problem without a more production-like data stream. So we fixed the problem, and you know, what are you going to do at this point, right? So we crossed our fingers and our toes this time, and everything else we could possibly cross. And we shipped to production again. Back on the conference call with IT. And this time, I mean, there must have been like 50 people on this conference call. And we were all watching these real-time activity charts and holding our breath as they booted up the software. And finally, everything was okay. And so we went home that night feeling relieved that things would finally go back to normal again. And then about 3 a.m., my phone rang. And it was my team lead calling me. And he asked me about some code that I'd written. And I knew exactly what happened. I'd been making some improvements to the code, and I accidentally introduced a memory leak that ground the system to a screeching halt. Once again, every tool in the entire factory shut down. So I told my team lead, go ahead and roll back the release again. But this time, the rollback fails. So here we are at 3 a.m., production is down, and we can't get our software out of production. So I crack open my laptop, work through the entire night, do an emergency patch fix to get things going again. And then, I got to go back to work the next day. And we were in this retrospective meeting talking about what are we going to do? Our tests aren't catching our bugs. We're trying to do all the right things, but it's not working. And then one of my teammates said, well, if we don't understand a problem, we should collect data. So then we started thinking about, well, what data would help us actually understand this problem? And so I thought the problem was technical debt that was building up in the code base and causing us to make mistakes. And so I wrote this tool that could detect high-risk changes in the code and let us know where we needed to do extra testing. But what I found wasn't what I expected at all. And that most of our mistakes were actually in the most well-written parts of the system. The mistakes were in the crafty code like we thought they were going to be. The mistakes were in the code written by our most senior engineers. And we looked around in the data and we just didn't know what to do with that at first. But the correlation we did find in the data was this. We made significantly more mistakes in the code that we didn't write ourselves. And that made some sense, lower familiarity, increasing the likelihood of mistakes. But I couldn't help but think there had to be more to the story than that. I mean, this is what I knew. When I had to work with complex code, it was really painful. But what made development actually feel painful? And so I started keeping track of my painful experience with the code and visualizing it on a timeline like this. So the pain started when I ran into some unexpected behavior and ended when the problem was resolved. So this is 5 hours and 18 minutes of troubleshooting. Would all of you agree that's pretty painful? So the amount of pain then was driven by two factors, the likeliness of unexpected behavior and the constant troubleshoot and repair the problems. And so if I wanted to understand the things that were causing the pain, I needed to understand the things causing these two factors. And so we started breaking down our problems into categories. And what we found as we did this is most of the pain was actually caused by human factors rather than problems inside the code itself. So for example, stale memory mistakes. This is when I have an idea in my head about how the code is supposed to work, but it doesn't work that way anymore because somebody changed it. Or ambiguous clues. This is when you're running an experiment and there's multiple possibilities for how behavior can occur, and you make a bad assumption and down the rabbit hole you go, troubleshooting for hours. So these aren't really problems inside the code itself. Pain is a consequence of how we interact with the code. Or I started thinking about it this way. Pain occurs during the process of understanding and extending the software. And so we started optimizing for what I call idea flow, or this flow of ideas between the developer and the software, rather than optimizing for the code itself. And so we did that with the help of a data-driven feedback loop. And this is what my book is about. It's a method for data-driven improvement in software development. And so my team ended up spending tons of time working on improvements that didn't make much difference for almost a year. And we had tons of automation, but the automation didn't catch our bugs. And we had well-modularized code, but it was still extremely time-consuming to troubleshoot defects. And then we started asking, what are the specific problems that are causing the team's pain? And that's when everything finally changed, and we were able to turn our project around. And I learned one of the most valuable lessons in my career. The hard part isn't solving the problems, it's identifying the right problems to solve. The hard part isn't solving the problems, it's identifying the right problems to solve. So what I want to talk about today is what changed on our team. Because this wasn't really just a journey in understanding problems in our code, this was a journey in understanding ourselves. And our project was really, really messed up. I mean, we completely went off the rails. But on the other side of tragedy, something beautiful happened. We learned how to learn together as a team. And then a few years later, I read this book, which totally changed my life, The Fifth Discipline, The Art and Practice of a Learning Organization by Peter Sankey. Has anybody read this book? One person. All right, add this to your reading list, all right? But it sounded exactly like what my team was doing as far as learning goes, but on a bigger scale. I couldn't help but think, this is the type of world that I want to live in. A world where business is about inspiring people to greatness and empowering people to achieve their greatest dreams by learning together. It's this awesomely beautiful dream. And then I started thinking, well, what if we learned how to learn together as a community, as an industry, as a society, as a species? And what if we started thinking about the world as one big design problem and using our engineering skills to conquer the biggest challenges in the world? And I know that might seem like a crazy, lofty idea, but the type of learning culture we need to get there, whether we're talking talking about something happening in a team or an organization or a community or an industry, it's really fundamentally the same. But when I bring up these ideas to engineers, you know, and solving human systems problems, they're like, humans? That's a scary thought. Coding problems, you know, we know how to solve this stuff. We've got computers that talk to each other. They got network problems. We got this, right? But human problems, we panic when we've got communication problems. So what do we do about this? Well, I read this other book, Predictably Irrational. It's on behavioral economics, but the core idea of the book is that even though humans make irrational decisions, they make predictably irrational decisions, and that we can build models of their behavior into our economic models. And so that gave me this kind of crazy idea of what if I could explain humans like code? Then humans basically become an engineering problem. So we got communication problems, we got tools for this too. We can fix this, they're just machines, right? So this talk is essentially going to be about culture from the inside out. So we're going to talk about humans and pretend they're code, right? And then look at how we can solve these problems and build a learning culture thinking about humans like code, all right? You ready? So imagine a human is a decision-making engine written in code. And we've got inputs in terms of ideas. We've got output in terms of decisions. Then we've got a database to store our memories, right? Then we've got a pain signal, an awesome signal, a feedback loop for improving our decisions, and then our goal as a human is to minimize pain and maximize awesome, all right? So first, recognition. How do we get ideas inside our head? So this is a synthesis of the research in 2 books on intelligence, how our brains work, and metaphors we live by, which is kind of a theory of understanding. So think of the concept as a metaphorical shape, if you will. So imagine that your brain is like a shaped toy, but with a face. And you look out into the world and you see all of these patterns, all of these different shapes out there. And so you ask kind of, do I know this pattern? And if you recognize the pattern, you take the shape and kind of shove it into your shape toy brain, okay? Just go with it. And if, you know, I just see a bunch of squiggles out in the world that don't match any of my patterns, I don't actually see anything. And then no shape basically equals no recognition. So an example of this, let's say a friend asks us, what is closure? And we know what closure is, so we've got this idea of closure in our head, and so we try and communicate this idea to our friend. But our friend, unfortunately, only hears gibberish, right? So the way this actually works is recognition is this bottom-up processing. So we've got these sensory signals that hit the bottom layers of our brain, and through this process of summarize, we come out with this pattern or this concept that we know as closure. But when recognition fails, we have the same processing. It goes summarize, but we don't get into any resolved pattern, and we get this kind of confusion at the top layers of our brain. So to solve this problem and communicate, essentially all shapes are defined relative to old shapes. So we have this problem we're trying to understand closure. Well, what existing shapes do we have in our brain? Well, I've got Lisp, which I know is a functional language, and I've got Groovy, which is a JVM language. And I can put these concepts together to give me a base concept of closure. And this obviously isn't everything you need to know about closure, as you might have learned here already. But at the same time, it gives us a foundation to build all these other concepts on top of. But we have to start with the existing shapes and work from there. So that brings us to brain hack number 1. I guess I forgot to tell you that I was going to teach you a bunch of brain hacks. But here's brain hack number 1. How can you improve your ability to communicate with your peers and recognize more details in your experience? Simple trick. Expand your vocabulary of shapes. Expand your vocabulary of shapes. So just by giving the patterns that you see a name, that's 2 major effects. So 1, you start seeing more details in your experience that you didn't recognize just by giving those things a name, because you've got more shapes in your shape toy brain. And so you start making all these connections just by giving all these tacit knowledge ideas labels. And number two, as opposed to having conversations with our peers that are all in terms of pronouns, you've essentially got a compression algorithm, if you will, for communicating with your peers. You can start speaking in terms of a rich language of nouns and verbs, as opposed to just, you know, that thing that happened last week, oh yeah, I remember that thing. You know, we have conversations like this all the time, right? So having just, you know, a list of patterns, and it doesn't need to be anything fancy, we just basically keep our own little hashtag language that we end up making up, and then using that in our requirements and all of our communication to communicate. So that's recognition. Next, we're going to go to the database. How are shapes combined to create meaning? All right, so there's 3 different base classes for concepts. We've got thing patterns, relationship patterns, and process patterns. And these concepts basically give us a way to reference our feelings. So you can think of it like a concept like an index and a hash map. So for example, we've got tech debt that might be associated with feelings of anger. Or we've got marriage that might be associated with feelings of love. Or maybe my last quote review, I've got a whole roller coaster of feelings going on with the process pattern. So we've got 2 main base classes for thing patterns. So a physical object in the world, or a personal reference to ourselves, so a pattern of I. And then for relationship patterns, we've got containers of an in-group and an out-group, or directions. So you can think of up and down being associated with better or worse. And these are just a handful of examples. But if you put things in containers together, this gives you the foundation of identity. So I've got a human identity and an object identity here. So the fundamental difference between a human identity and an object identity is not whether the thing you're referring to is a human and an object. It's a little bit different. So for example, class cat extends I. Class chicken extends object. The fundamental difference here is in one case we have empathy, in the other case we short-circuit empathy. And this is why we can eat a chicken, but not a cat. And direction metaphors give us rank. So we can rank people, we can rank objects, and we can rank containers. And humans really love to rank things. So we've got the 30 healthiest foods of all time, the top 10 restaurants, or who has the highest DPS in Warcraft. So comparing and ranking things is how our brains make sense of the world. So we turn all the similarities and differences we see into containers, and then rank everything as a way to identify the things that are most important. So you can imagine that when we meet a person, we compare that person to our system of containers and ranks in order to build a conceptual model of that person's identity. And then we do the same thing to establish our personal identity by comparing ourselves to the same system of containers and ranks. So containers have this huge effect on the way we understand things, specifically around how we compare things. So when 2 things are inside the same in-group, we look for similarities. Where when they're an in-group and out-group, we look for differences. So this ends up having a huge impact on human behavior. So for example, we're pre-wired to model the in-group with similarity-seeking behavior, right? So you, in this case, always extends from I. I want to be just like you because you're in my in-group. That's the way the world ought to be. So an example of this, here's my team, and we write unit tests, and we pair program, and you want to be on my team. So I ask you, do you do these things? And what do you say? Yes. and this is like so ingrained is that we don't even realize that we're doing it. But you know, we model the groups that we want to be in, that we identify with. And likewise, we're pre-wired to objectify the out-group. So this is difference-seeking behavior. So in this case, you always extend from object. You're nothing like me. So we push that as far away from as possible and make people into objects. So for example, developers and testers. Testers extend from objects. Testers are a tool for us to use. And on top of this, we usually have a superiority complex. On top of it is thinking that we're better than testers, right? Or another example, smart people, idiots. Idiots extend from objects. Idiots are a tool for us to use. So have you ever looked at the world through this lens, huh? Anybody? So the point I'm trying to make here is as soon as I decide that someone is not like me, and I shift them to this pattern, I also short circuit empathy. And this is why we act like assholes. So this brings us to brain hack number 2. How do you stop being an asshole? So the trick here is to rewire your brain for empathy. So you ready? Here's how you do this. This is the answer to world peace right here. So let's say I've got this person and I just have all these feelings of disgust. Maybe they're a tester and they support a political candidate we don't like. Just too much, right? So here's how you rewire your brain. World peace right here. This is the recipe. Step 1, stop and think. Is this a person or an object? Step 2, choose person. And what happens here is, we start mapping that to a person, and then we go to similarity-seeking behavior. Now we have to find all these ways that we're similar to this person, and these feelings of disgust basically get mapped as feelings of pity. And while that's not necessarily great either, it's a much better place to start a relationship. All right. So we're also pre-wired to extend identity to offspring. So this is me, this is my baby. My baby extends from I. My baby is a part of me, right? So we're also pre-wired to extend identity to soul class. This is me, this is my code. Class my code extends from I. So the problem we have here is then when somebody comes up and says, your code sucks, it hurts, right? It's personal. Our code is us, right? It's an extension of ourselves. So, brain hack number 3. How do you stop feeling defensive? Same basic trick. Rewire your brain to disable empathy. So here we go. In a code review, we've got somebody telling us our code sucks. It's really painful. What are we going to do, right? So here's how you rewire your brain. First, stop and think. Is my code a person or an object? Step 2, choose object. And what you see happen is the same pattern. As soon as we turn that identity into an object, we disable empathy, and these feelings of pain kind of melt away, and then we can start having an objective conversation about our code so we can learn and improve. So just say to yourself over and over again, I am not my code, I am not my code. And eventually it'll start sinking in. All right, so moving on. Where do gut feelings, where do gut feel decisions come from? So this is where we get into all these different pain and awesome signals. So this is coming from the feeling machine. So this is our orbital frontal cortex plus our limbic system, which has this cool characteristic of giving us this summarized body response and giving us all these different character feelings. But they're always on the scale of pain to awesome. So let's take a simple example to start with. So you're having lunch, you're like, do I want a fruit or a salad? Okay? So the way this works, we don't normally think about our body being involved in decision making, but this is exactly what happens. We think fruit and simulate the body experience of eating fruit, and we get a signal back. Not so much, not feeling like fruit today. Think salad, simulate the body experience. Salad sounds fairly awesome. And the same thing goes when we interact with people. Do I like Sally? Well, we'll think about Sally and simulate the body experience. I think I like Sally quite a bit. Do I like George? Same thing. Think about George, simulate the body experience. Not liking George so much. And this is how we make decisions. But when it comes to more complex decisions, we have to there's a lot more going on here. So if you imagine that you set a breakpoint in your brain, you can think about, in that moment, your decision is kind of like a function that has inputs, evaluation, and a decision you're making. And in that moment of the decision, we have all these feelings that come to mind when we think about our different choices. So for example, should I write a test? I think you should write a test. Should I skip the test? Probably a bad idea. Should I delete all the code? That sounds like an awesome plan, right? So we've got these different feelings that come to mind in our decisions. Well, where do these feelings actually come from? And so this gets into the process patterns that we talked about a little bit earlier. So the base class for process pattern is a journey, a beginning and an end. We've got these obstacles we hop over along the way. So you can think of a journey as capturing the roller coaster of human experience. So what were the challenges on the journey? We've got constraints like walls we're running into, which can be associated with feelings of frustration, or friction, like little mud piles that we're running into, and this might be associated with feelings of pain, or a strategy to go around the mud, and these might be associated with feelings of victory. But no matter what happens, and we might weave all kinds of stories together, journeys always end in pain or awesome, and we tend to always remember how stories end. And you can think of these journeys as being constructed of a bunch of these changeable parts. We've got a situation that we're in, a strategy we use, and then a consequence that ends up occurring as an effect. And so imagine, for an example, I just brought down production 3 times in a row. So just hypothetical case here. Let's pretend. So how do I avoid the pain next time? I've got this bad situation that occurs. The next thing I do, if I want to avoid this, is I get my consciousness involved, say, well, what if I had done things differently, right? What if I had checked the configs before we shipped the version? Or what if I had better tests that could have, caught these bugs? And I think about these alternative possibilities, and I'm like, okay, next time I'll do better because I, could have done these other things. And so what happens is these story patterns, these hypothetical ones, combined with the initial stuff that happened from our experience, get combined together to create this prediction machine. So what happens then, we see a situation that's similar to the situation in the past, and we sense the pain from all those consequences that happened in the past, and then the strategies come to mind just from the simple heuristic of minimize pain, maximize awesome, and then we intuit, whatever these strategies are that we did in our simulation. So gut feel basically arises through this basic mechanic of pattern reinforcement. But the problem is, typical developer pain sensors are a little bit out of whack. So ugliness tends to bother us a lot. Like, we don't want to have an ugly baby. Nobody wants an ugly baby, right? But difficulty is enjoyable. And so what happens is exactly what you might expect to happen, is our gut feel assumptions about the right thing to do get terribly miscalibrated. And our entire discipline has evolved in the absence of any kind of feedback loop. I mean, think about the implications of that. Our entire discipline has evolved in the absence of any kind of feedback loop. So that brings us to brain hack number 4. How can you recalibrate your pain sensors? This is where visualization comes in. And don't really underestimate the power of visualization. Our brains are pattern matching engines. And just by visualizing all of these patterns of how long things take, we can actually internalize a ton of this information even if we don't realize it. But even if you don't visualize your pain, there's something really simple that you can do. Is if you want to avoid something, start calling it pain. And those things will wire together in your brain. Your pain matrix will light up with whatever this thing you're thinking about. And likewise, if you want to desire it, call it awesome. And just doing those basic rewirings, you can start affecting your gut feel decision making about those things. Make sense? All right. So now let's put the whole thing together and put the brain in motion. So see how this thing works with the context of feedback loop. So this is based on the synthesis of research in Rewire Your Brain and Leadership and Self-Deception. And these books totally don't go together at all, but I think that's what makes this all the more awesome. All right, so our brain is basically constantly making predictions. So imagine you're in this moment, there's all these patterns that happen that you recognize, everything's just fine. And in any given moment, you're making a prediction about what you're going to see next. And we only update our brain code when our predictions fail. So as soon as you have a violated prediction, there's literally a flood of chemicals in your brain that allows for rewiring to happen that doesn't happen otherwise. So the way you can think about this, imagine you're kind of walking down the stairs. Everything's fine, you're just kind of thinking about something else. At this point, all your predictions are confirmed. And then you get down to that last step. It's not quite where it's supposed to be. And suddenly, everything in your body is paying attention. Do I need to grab the rail? Do I need to brace myself? This is a violated prediction, right? Or another way to think about this is the WTF moment, or runtime exception that bubbles up to the top of our brain. WTF, we gotta figure out what's going on. And at this moment, our consciousness is summoned to pay attention, to deal with the current circumstance, possibly with a load of adrenaline too. And then after this happens, we have to repair our prediction machine. We've got that surge of chemicals that comes in to rewire our brain. And so in this case, you can think of this as constructing a story to make sense of the situation. So I stepped down the stairs, I tripped and fell, and then I started thinking about, well, if I had been holding on to the railing, I wouldn't have fallen, right? And so we've got that alternative pattern, and now next time we walk down the stairs and we're in that similar situation, we remember that we were supposed to grab the rail and instinctively do it because it's wired into our brain. Just constructing that new story to make sense of things. So the other time we run into violated predictions is with social rejection. So my identity predicted I should be included in this group. But the group said, no, WTF, that wasn't supposed to happen, right? Except now we've got pain associated with the situation too. So what happens? Basically the same thing, is our consciousness gets involved, but this time we have to repair identity. So how do we repair our identity? So here's me in this group that I wanted to be part of, and I've got pain associated with this experience. So the easiest way to solve this problem is turn the in-group into an out-group, which maps pain to disgust. And usually to make this happen, I gotta tell myself a whole pack of lies to make this whole story make sense, right? And then we've got a friend who comes over and challenges us on this pack of lies we're telling ourselves, which triggers all this pain from the past. So how do we solve this problem? Well, our friend probably wasn't actually our friend after all. And now we can get rid of this problem here with having pain. But self-deception is essentially a coping strategy for resolving identity conflict. So we defend our lies as a means of minimizing pain. It's that same heuristic: minimize pain, maximize awesome. This is often easier than dealing with all that pain and rejection from the past. But the problem is, then we end up in this downward spiral. So if you imagine I've got my personal truth in the center, and then I've got identity and self-deception on the outside. And then I've got my sense of what I ought to do, or my authentic path, if you will. And I've got all these lies that are steering me in another direction. And what happens is the more that we deviate our decisions, the more we have to rationalize the decisions that we just made, which leads to more and more of all this same baggage, right? Kind of building up over time. So the problem then is, after we get buried in all of these lies, that inner sense of the direction that we ought to be heading down sort of drifts away, and we actually lose touch with ourselves. So this is what we call emotional baggage. And the problem is these things shouldn't be relevant in software, I guess, but the problem is we can't learn together as a team when we've got people that are always on the defensive. And every time you've got someone that's got lots of baggage, they cause lots of problems on the team. So how do we escape the downward spiral? Brain hack number 5. So solution to this, identity 2.0. So identity 1.0 is I am the sum of the past, or think of the database as me. Identity 2.0, I am the one who chooses the moment, so consciousness is me. So the way to think about this is Identity 2.0 is a principle of continuous choice. So ask yourself the question, what are the choices that you can make every day that define who you are as a person? What are the choices that you can make every day that define who you are? And essentially what we're going to do is refactor this base class of identity, which is going to have a ripple effect on all these other systems. So when I started thinking about this question, I started thinking about my team and what were the choices that we believed in. And our project, as I mentioned, was really broken. And this tragedy had a way of just bringing us together. And no matter how hard things got, we didn't give up. And we believed in ourselves, and we believed in each other, and we believed that we could get through all this if we were willing to work together. And so I started thinking about this and extracting the choices that we made into 5 principles that I call the clear mindset of courage, leadership, empathy, authenticity, and respect. Remember, Identity 2.0 is a principle of continuous choice. So courage isn't the absence of fear. It's the decision to do it anyway, despite fear. And leadership is a decision to carry the torch, to commit to the journey, however long the journey takes. And empathy is a decision to be patient in understanding each other, and patient even in understanding ourselves. And authenticity isn't the lack of a filter, like a lot of people want to think. It's the lack of self-deception. It's the decision to seek truth. And respect is the decision to see other people as humans with thoughts and feelings similar to our own. So basically, the no asshole rule. And essentially what happens when we start forcing choices and overriding our intuition and acting according to our principles instead, we violate our own predictions. And so we get that same surge of chemicals that allows us to rewire our brain. And we can ask basically, what is true? And go back to thinking about and reevaluating all this stuff that happened in the past. And because we no longer have a need for all these lies anymore, because they no longer define who we are as a person, because we've defined ourselves in terms of principles, all this baggage just starts melting away. And we get back in touch with that kind of authentic person we are on the inside. So far I've been talking about stuff, internally with ourselves. But how do we build a clear culture on our team? So we've got this problem of not being able to control other people, right? So the solution I found with this is to choose the path we want others to follow. So think of culture as an emergent property of all these different human beings kind of interacting with each other. And from that effect, culture kind of emerges. But the only thing we actually control is our personal mindset. There's only I who chooses, right? But remember, we're pre-wired to model the in-group, so you can take advantage of this fact. And when you step up and lead, the people on your team will model your choices. So if you want people to start measuring their pain, then start doing it yourself and share what you're doing and why. And if you want people to espouse clear values, then start doing it yourself and share what you're doing and why. And what you see happen is, one person will join in, and another, and eventually it just kind of becomes a thing. And this is how you ultimately get here. And then, once you have this clear learning culture, you can put the pain on center stage with objective data, and then learn your way to awesome by working together. All right, so that's a clear culture. So I've got one more thing that I wanted to say before I wrap this up. So the world around us is pretty messed up right now. And the state of our government in this crazy election, it's just depressing. And I know it's really easy to get cynical about any kind of changes being impossible. But change starts with a decision to take a different path. And if we zoom out, like way out here, here's us humans in the middle of the lonely galaxy. And we all want the world to be different, but we all feel helpless to do anything about our problems. So why are we helpless? Why are these poor humans in the middle of a lonely galaxy helpless to do anything about their problems? There's two main reasons. One, we are crippled by our inability to work together. And two, we are crippled by the decisions of the past, because a few hundred years ago, a handful of humans made some design decisions about our infrastructure, and our blueprints for running the world now have a few bugs. So you can think of the state of the world today as a consequence of our blueprints, in the same way that we get unmaintainable software as a consequence of bad architecture decisions. And as Einstein said, we can't solve problems by using the same kind of thinking we used when we created them. And we're expecting politicians and lawmakers to somehow figure out how to get us out of this mess. And it's never really going to happen. And it doesn't really matter who the hell we vote for. This dysfunction isn't fundamentally going to change, because this is a design problem. This is an engineering problem. And the people with the engineering skills to actually solve the type of problems we have right now are people like us. And once we start thinking about humans as code, and how information flows across social networks, and how decisions are ultimately made, the world starts to look like one big design problem. So next year, I'm going to be doing a whole series on human systems architecture and how we can use software as a metaphor for designing our organizational blueprints, starting with happy humans as a design constraint, and then totally reinventing our modern organizational architecture so we can start fixing the insanity that is our lives in software development. But what if we designed the blueprints? What if we made up the rules? What if we could erase everything and start over? What type of future would you build? What does awesome look like to you? Before we figure out how we're going to get there, let's figure out where it is we're even trying to go. And as I mentioned before, I want to live a world that inspires people to greatness and empowers people to achieve their greatest dreams. This is the vision of the fifth discipline. So to build a world that inspires people to greatness and empowers people to achieve their greatest dreams is to build a world of learning organizations. And open mastery is about using our engineering skills to bring this vision to life. So I believe the path to better starts with us learning how to learn together as a software community. If you think about it, we are the engineers of the most powerful industry on our planet. And if there's anyone out there that has the power to change the world, it is us. If we can start learning how to work together and learn together as an industry, we have the power to re-engineer our world. And I know this sounds like a pie-in-the-sky dream, and that, I just have my head in the clouds, but I've got a strategy that goes from visibility and intelligence tools for engineers to reinvented business accounting for organizations to mastery-level education that's free to the world to a strategy to redesign the economy in a way that supports the people while simultaneously eliminating the tax system. Free education and no more taxes. Sounds pretty good, huh? And I realize this is a gigantic undertaking, but this is why we iterate. We start with visibility. We move toward awesome. We start with our team. Then we move toward our industry, one small step at a time. So the first step in making any of this happen is measuring your pain. And so on January 1st, we're launching our open source tools pilot for automatically measuring developer experience. And the tools integrate with your IDE, You don't have to do anything, but the more you tell the tools about the subtasks you're working on, the pain you're experiencing, and the awesome events, the more accurate the resulting data that'll come out of the tools. And this data will basically be the foundation for one of those kick-ass developer intelligence platforms you can ever imagine, which is the topic of conversation tomorrow if you want to talk automated developer insights, the next frontier. So I'll give you a demo of the initial tools, and we'll have a discussion about how to get from A to B. And then so that you know how to learn with this data, the engineers at Blackbaud, one of the most incredible engineering companies I've worked with, they're learning out loud as an example for the community. So all you have to do if you want to see what a learning culture looks like in practice is join our meetings on Google Hangouts and watch what we do and then start learning with us. But I can't do this alone. So I'm here to ask you to give this a chance. I'm asking you to believe in yourselves and to believe in each other, that we have the power to solve any problem we choose to solve if we're willing to work together. We have the power to choose the future that we want if we're willing to work together and learn together as an industry. We really do. All we have to do is believe. I know it sounds like a cat poster, but it's true. You guys have seen this movie, right? I hope so. So watch this movie again and just, imagine we're the master builders. And then think about how do we learn our way to an awesome world as a community? How do we get from where we are now to where we want to be? Think of it as an engineering problem. If you start with the assumption that working together is an option, how do we actually get there? At that point, we need a strategy, as opposed to just railing against the machine and trying to throw lots of pebbles and not actually doing any good. We need a strategy to actually get someplace better. So, Open Mastery 2017, we're really going to do this. So I've committed my life to leading this effort. I'm carrying the torch for this dream. So if you're willing to join me in making the world around you a little more awesome, then pull out your phone, send me an email at janelle@openmastery.org with the email subject of Tools Pilot, and include your IDE editor and OS. And I'll send you an invite to Slack, a coupon for a free ebook, and an ETA on support for your environment. And January 1st, we'll have support for IntelliJ. And if you come and find me, I'll hook you up with an awesome torch sticker for your laptop. But remember, the only thing really stopping us from conquering the biggest challenges in the world is making the decision to try. Thank you.